The stream is about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause the stream is about to start. Get ready wherever you are, 'cause the stream is about to start. Hi, my name is Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is to continue what we have been doing this week, and that is to smooth the scene transitions in the Automixer for video. In case you're new here, as a quick recap, we have been working on audio effects and now video effects as well in the JSFX language in REAPER. We have been doing that for more than 1 year at this point. And right now we are working on this effect called Automixer. And what it does is to allocate the gain of different microphones that may be open in the same room. So think of an interview, a round table, that sort of thing. And you want to prevent the bleed that occurs when one person is speaking and their voice is picked up by all other microphones in the room because of room reflections and that sort of thing. So that's the audio portion of the Automixer. The video portion of it is that you are able to switch different cameras. So now in this scenario, there are multiple microphones in the round table, but there are also multiple cameras, and you can switch to the camera of the person who is speaking based on how loud their microphone sounds. Mage is here. Hello. Great to see you. So the bulk of this week's work on the Automixer was to smooth the scene transitions. When someone starts speaking, we may not necessarily want to switch to that person right away. And after we have switched the camera, we may not want to switch again too fast, because that is just weird editing, I guess. And today, what we are going to look at is another case of those. It is avoiding scene transitions that would not make sense. And what I mean by this is, if there are multiple people talking at the same time, then you may want to continue showing the person who was speaking. You may not want to, so we are going to give a slider for the user to decide on what to do there. But if they want to, let's say, prioritize the person who is already speaking, then we will have a way of doing that. And the way that we'll do that is that in order to register as a new person speaking, you have to not only be the loudest, you have to be louder than the rest by a margin. And that's a given margin that the user will select. Perhaps this is a bit too abstract. So let's switch to this and start by creating a test case for this. In fact, perhaps we should be creating test cases for these other parameters in a more principled way. And we sort of have a setup going here, but it is not too easy to reproduce, I think. So let's delete these items because they're junk. Let's delete this item. It's also junk. And let's create real quick an item here that is a sine wave at 0 dB. And you can see that now it is a sine wave that goes all the way down and all the way up, touching but never passing the 0 dB mark. And the reason why I wanted to have an item like this is that it will be easier to change its volume. So now we know that we have a sine wave at minus 13 dB, for instance. And it will be easier for us to document what the test scenarios are supposed to do. Better than this other sine wave that has whatever loudness and then plus 3 with respect to what, really. Hard to tell. So let's use this new item for the tests. And of course, we are simulating people here with sine waves, as one does. So for the attack, what I want is for the two people to overlap. Well, not quite. I don't want them to overlap. I want them to just transition from one to the other. And what I want the Automixer for video to do is to switch from this camera to that after a little while. I don't want the transition to happen right away. That's the attack. And we implemented this, I think, on Monday. Let's review the setup we have for the Automixer here. We have video turned on, but some of the settings we changed. So I'm going to erase this Automixer instance and add a fresh one. So I want to turn on video. I don't think I will change any of these settings. Not now anyway, and I will say that this is video track number 2. And then here we have this very hacky way of seeing what the scene transitions would be in terms of audio. It is 0 or 1 in terms of audio, and then we can see the scene transitions happening. So if I start recording now, and this is enabled for recording, then we see the scene transition taking a little bit of time. That's the attack parameter. And if I increase the attack, we should see more of a delay before the scene transition. And I think we do see more of a delay. And I will keep this as a reference of what we expect as the result of this test. Then for hold, we will have this situation in which one person is speaking, then another person starts speaking, but just long enough for the attack to go through. And then we switch back to person number 1. So this scene transition is supposed to hold, so this scene transition is supposed to take longer. It should occur right here, for instance. So for this test, I will let the attack be the default, but I will increase the hold, let it be a full second. And let's see what this looks like. Yeah, this is perfect. Perhaps I will extend this a little bit just to make it clearer. But check this out. The first scene transition occurs immediately. The second one needs to wait. That's the hold parameter. Then for the threshold, what we want in that case is to not do scene transitions when we are below a certain threshold. And that's because we don't want to have scene transitions when no one is speaking. You don't want someone who is just breathing loudly to be on camera. So what we do is this. So now if we reset the attack and the hold, and the threshold is -40, then because this one is -60, the scene transition should not occur here. It should wait until we get there, and then it should occur. Perfect. It is even a bit ahead because of issues that we already talked about in previous streams having to do with predictive processing. But anyway, this is the behavior we want. And note how I put these two items with enough length for attack and hold to not be a major factor in this test scenario. So with all of this, we have a much better structured test situation going here. It's by no means like automated tests, but it's good enough. Bo is here. Hello, Bo. I am doing good. I hope you are doing good. Yeah, all right. So let's get to a test scenario for the relative differences between microphones. Let's make a section here. A region, I should say. Let's make a region here. And I will call this one minimum difference. So this test scenario goes like this. There is someone speaking. And let's say that this person is at -18. So well above the threshold, no problem there. And then the second person starts speaking, sort of interrupting or interjecting. But that person is at -17. This person is being louder, but by only 1 dB. So they are being louder, they are interrupting, and you may want to switch them, but you may not want to switch them because there is not enough a difference. And I guess this is also relevant when multiple people start speaking, then the Automixer would be confused about who is the winner. So what we are going to do in this case is avoid doing a scene transition because we are not sure enough who should be on camera. Just keep it as it was. First of all, let's see what the Automixer currently does. I think it switches to this person. I will make it long enough. I think it will switch to that person. Yes, it is switching to that person and then switching back because, strictly speaking, this person is louder. So it makes sense that the Automixer goes to that person. But with this new setting that we are going to implement, we will keep the camera on the first person at all times. If you are an editor, maybe you want to show the person who is interrupting. So in that case, you would disable this setting. But anyway, minimum difference. I guess it is like hysteresis in gates and that sort of thing. It's trying to prevent, I guess, jitter in the scene transitions. All right, let's get to it. Let's implement this parameter. So there is this threshold. I think that what we are going for is similar to the threshold. So I will put it here. And then we have an envelope. So I guess I'll put it here. This will be the new slider H. And this will be the minimum difference. And I would like to say that this is in dB, but for technical reasons that we are about to get into when we actually see the code that implements this slider, I don't think it will be in dB. I think it will be just a number. And you will have to calibrate it by looking at the results and seeing if you like it. Because I think that we will implement the minimum difference using the normalized gains. And I think that that normalized gain is not in dB. So that number is not a meaningful number. It's not nothing we can put our fingers on. So we'll just go from 0 to 1 in steps of 0.01. 0 is I guess the current behavior, right? We don't look at a minimum difference at all. 1 would be one person has to be completely quiet for a scene transition to occur. So that is, of course, heavy-handed. And then everything in between, I guess we will do like 25% or something, which is reasonable, right? You would expect someone to be 25% louder than someone else in conversation, as long as they're not talking on top of each other. So you would expect, I guess, a 25% difference between one person speaking and the bleed of that person into someone else's microphone. And this is not the threshold, this is the minimum difference. And this is another one of those group parameters that we have to sync across plugin instances. So now we are going to get into a bunch of copy and paste. But before we do, if you want the camera, then start shouting. As one does, right? As one does. It seems like that's what everyone is doing these days. What we'll do is we are going to look for this, and then we will apply the same to the minimum difference. We will need a default, which in this case is that. We'll need to put this in the data structure. For people who were watching our Wednesday stream with Pale about iPlug, this should feel familiar because the parameters of a plugin were declared in an enumeration. In that case, you would only say equals 0 and you wouldn't have to say equals everything else. It would just auto increment. But in our case here in JSFX, we have to be explicit. And then using the last number as the size of the data structure. Same story here. All right. I have one idea to make this kind of code simpler, so we wouldn't have to copy and paste so much anytime we add a single slider. If we have time, maybe I will get into that today. I think I finally thought, but I haven't really coded, so I haven't really fleshed out the idea, but I think I have a way of having the group parameter sync without having to copy and paste and have so much boilerplate. Realistically, I don't think I will have the time to get to that, but just so you know that perhaps the days of agony will be in our past when we finally get around to this. I think we did it. Let's open the Automixer and see if the new slider is syncing. So I have two instances of the plugin, both on group 1, and here is our minimum difference, and it is syncing. Perfect. So now we can actually use this when we are doing the scene transitions. So that occurs way below in the code, about here. So if the video is turned on, we will do all of this. Not much, but that's what is doing the scene transitions. And I think that the way this is going to work is we have this, which is taking care of the threshold. And then we have this, which will be in terms of, oh, look at that. We already have a comparison for the gain here. So I think that what we need is just this. Let's recap what this line is doing and how this will probably implement the feature that we are looking for. So what this line is doing is we computed the gain for the current instance that we are at. So for instance, we computed the gain for person 1. We also computed the maximum gain of all the other plugin instances, which in this case is only person 2, but you get the point. So this is the maximum of all other tracks. And this gain is normalized. It is a number between 0 and 1. So is this. It is normalized as well. So in other words, the gain is the percentage. How much gain should be allocated to this microphone? Well, its contribution to the total. That's the gain that is allocated to it. That's the core of the auto-mixing algorithm. But if we say that I don't want to only be greater than the maximum, I also want to be greater than the maximum plus the minimum difference, then I am making you work harder. Now gain has to be even larger in comparison to this to kick in the process of switching scenes. So, coming back to my explanation that if this is 0, it is the old behavior. Yes, it is, because plus 0 will not change anything. And if this is 1, then the other tracks need to be exactly 0, and this needs to be exactly 1, which is feasible in our sine waves, but not really in the actual conversations, right? Anyway, with this, I think that we have the right behavior now. Let's see. Awesome. So it is not doing any scene transitions. But just for completeness, I think I will have one here that does a scene transition, so it will be much louder than the other fellow. So what I expect to happen now is this difference is small. We continue on person 1. This difference is large. We go to person 2 and then back to person 1. Awesome, that's it. That's the minimum difference. That was surprisingly fast. And yes, that's the person shouting right there. There is another notion of the minimum difference between microphones, which is not with respect to everyone else, like we just implemented. We implemented a notion of difference with respect to everyone else. It is also a notion of difference between the current instance and the previous winner, so to speak, the previous camera that was showing. The scenario I have in mind here is pretty tricky, but I think it is something that could happen. Suppose that one person is speaking. Well, I guess instead of just explaining this out loud, I better have the scenario here. I will try to draw it. This is person 3 now. We will need 3 people for this scenario. It gets really tricky. And this is like minimum difference with respect to previous person talking. So in this scenario, we first have good old person 1 talking. So far, so good. And then 2 people are going to start talking, and they are going to be, doesn't really matter, they're going to be the same loudness. In this scenario, this person stopped speaking, so lingering on them, probably not the best idea. You probably want to switch to these 2. Which one? Hard to tell because of this parameter that we have just implemented. No one is going to be significantly louder than the other. So we will not switch to either one because we don't know to which person to switch to. But lingering on this person is also not ideal. And yes, I think that's what will happen. So now we have 3 instances of the Automixer, and what I expect to see is for the camera to just continue on person 1. See? And I can make this difference very small, but still, no one is going to be picked up because 2 dB is not enough of a difference. And if I make this difference large, then we will switch to person 2. So I don't know if this should be a different slider or if it should be, I guess maybe this notion of difference is not the best one and this notion of difference is better. Certainly this notion of difference is easier to implement, and that's why I started with this one. Now I'm interested in exploring this notion of difference because now we are not talking about a difference between everyone else at the moment. We are talking about the difference between people who are talking and people who were on camera. Does it still make sense to keep that person on camera, or does it make sense to switch to someone? If you don't know how to pick because they are very close, then pick one. And maybe that subsumes this, because let's think about this. If we had a solution for this scenario, would it also solve this scenario? Maybe. Let's think this through. So in this scenario, we have one person that starts speaking, but only ever so slightly louder than the other person. But so far so good. So because if we implement this notion, then this is the person who is on camera. And this needs to be slightly louder than the person who is on camera. They will not be picked up because this difference is too small. But if they are much louder than a person who is on camera, then we switch to them. So I am tempted to say that even though this notion of difference is easier to implement, I think that this notion of difference is more useful. And I think that we should pursue it. I think that we need to keep some piece of information that we currently don't keep, and that is we need to know the gain of the person who is on camera. Well, we do have a notion of gain for everyone. Am I right? Yes, we do know the gain of every person, and we know the person who is on screen. I think that that's the person who is on screen. I don't really remember. I don't think that's the person who's on screen. That's a setting for whether video is turned on or not. Anyway, we do have a notion of who is on the screen, and we have a notion of the gain of that microphone. So we should be looking at that instead of just looking at all the other tracks. And I think that that will subsume this other tracks maximum. Yeah. Let's review every place where this variable is used. Luckily, it fits on the screen. So this is the place where we use that variable. We just saw this line. And this is the place where we compute that variable. So let's see what's happening here on this loop. We are looping over all the tracks. And we are doing some computation here that is necessary to compute the gain, so that doesn't change. And if the video is on, then we do this line, this weird situation that is gathering the maximum of all the other tracks. But now we are changing this notion. We don't want to compute the maximum of all the other tracks. We want to see what's the gain of the track that is currently on camera. I don't need to initialize this variable now because we will not be accumulating stuff into the variable. And I don't want to call it that. I want to call it like gain, or perhaps even video gain. Is this something that already exists in the code base? I don't think so. Yeah. And I will perhaps call this current camera. And what I will do is I will check that the video is on. We have to do work for video. And I will also check that this is the track, this track is equal to the track that is currently showing. Like so. So if the track is the one that is currently showing, then the current camera gain is the gain of that track. And then we are looking at the gain of that track when determining whether we want to switch to ourselves, if we want to switch cameras. Okay. So now we changed the notion of what is necessary for a camera switch to occur. It's not that we need to be the loudest. We just need to be louder than the person who was on camera. Which I guess makes sense, right? We don't want to necessarily be showing the loudest person. We just want to be showing someone who is louder than the person who was on camera. In a case of multiple people speaking, that's enough of a good situation. And in case people are not speaking at the same time, when someone stops speaking and someone else starts speaking, it stands to reason that that person will be louder than the person who was on camera. The only issue is if the person number one who is speaking stops speaking, person number two starts speaking, but they are so loud that the bleed of their voice on the other microphones is louder than the voice of person number one, which is something that sometimes happens. And in that scenario, then multiple tracks could be triggering this condition. And we could be switching to a track that is just bleed. So perhaps what I want is to have both. I want you to be the maximum, and I want you to have a certain difference against the current camera. Is that too confusing? I think it is very confusing. Are you going to have a CEO checkbox so the camera switches by passing some of the checks? Yeah, well, I guess the sliders are sort of doing that. We did a range of the slider that goes down to 0, for instance, if you don't want to have this behavior of the minimum difference. Right. So yeah, I guess in essence what I'm saying is, yes, we will let the operator enable and disable different settings according to their tastes. Okay, so I think that we want the previous notion as well as the new notion. The previous notion being we want to show the loudest track, and the current notion being we want it to be louder than the person who is speaking. I don't know, let's play around with this. The current notion should implement the idea I explained. Let's see if it does, and let's see if we like it. So I expect this scenario to not change. And it does not change. When the person is louder but not by a significant margin, we stay on the camera that we were. And if it is louder by a significant margin, then we switch. And I expect that this will now behave differently. We will either go to person 2 or person 3. And because these two are exactly as loud as one another, it's hard to tell which person we are going to go to. So in this case, I'm going to make a 1 dB difference. We know that 1 dB is not significant enough. It's below the minimum difference. So we know that this person will win. But only because we are comparing to that and not to this. Yeah, we went to person 1. Or sorry, we went to person 2. Just to be sure, person 3 would look like something that's clipping, because person 3 would be at I want to say plus 6 dB, something like that. Yeah, plus 6 dB. And now we are back at 0 dB. Why plus 6 dB, you may be thinking? Because the number 2 in linear corresponds to 6 dB. That's why. You can plug the number 2 into the dB formula and plus 6 will come out. Anyway, 6 dB represents doubling the amplitude. Enough of that. So we have the new behavior like we want. It goes to this person because they're louder than the person who was on the screen. But there is another scenario in which it would be useful to have a notion of who is the loudest microphone. That is the following scenario. You have one person speaking. And then you have someone else start speaking. And the bleed of that person into the microphone, into anyone else's microphone, is louder than, and I want this to be a significant margin. So let's make sure that this is very, very quiet. So say that this person speaks very softly. Then someone else starts speaking and they are like at -6, but the bleed of that person into someone else's microphone is significantly louder than. Let's make this number even smaller to give ourselves more margin. Yeah, someone is speaking very quietly, but they are on camera. Someone else starts speaking, but they speak so loud that the bleed of their speaking into someone else's microphone is louder than their voice of the other person who was speaking. And this is something that happens. Some people have round tables where someone is very quiet and someone is super loud, so the bleed of someone's speaking is louder than the other person speaking. And that's why this scenario is the reason why an Automixer is better than a gauge. If you tried to gauge this, you wouldn't be able to because the bleed is louder than the signal. That's why you need an Automixer that knows every microphone and that is effectively adapting that threshold according to how much signal is coming in. That's the whole point of having an Automixer. So I guess I will name this scenario bleed is louder than signal from someone else. And I think what I would like to do is to go to this because they are the person who are speaking. But this is already louder than that. So that there is a chance that this will be the camera that we switch to. Right now, these two are starting exactly at the same point. So, and also this instance was created first. So I think there is a fair chance that this will win and we'll see this going to +0 instead of +6. Let's give it a try. There is no reason why this needs to be so long. Yes, so we are going to 0. So this camera is winning, which is what we want. But I think that if I make this ever so slightly different, just like that. So suppose that for whatever reason, the echo reached someone else's microphone before the actual signal came in, maybe because of some jitter on the audio interface, you know, whatever. Just making a very small difference here, just to give this one a little edge, because then I think we'll see +6. Oh, now it's going to 0. Interesting. Let's give this a bit more of an edge, because we have this whole predictive thing going, so let's give it a little bit of an edge, but it must not be so much that we end up switching to this, because then there is the hold parameter. Yeah. Oh, and what's interesting is that we never switch back. We go to +6. Oh, I guess we do switch back. God damn it. It is hard to tell because when we switch to person 3, we are clipping the signal. Let's change the debug view to divide this by 10. And then we can see up to 10 people. Let's divide this by 5 because I think that we will not have more than 5 people and these 2 lines are too close. Okay, this is good enough of a view. So what's happening here is that we are switching to this camera and then to that one, and that stands to reason. And if we made this difference small, then we would get stuck on the bleed. But if we made this difference small, we are really thinking about a scenario that sort of looks like this, in which we do want to keep this. We want to keep the person on the screen because supposedly they are being interrupted by someone. So maybe this new behavior does everything we want it to do. Because this is the bleed. And let's give it a little less of an edge. Yeah, we switched to the wrong person real quick. That's maybe because the attack was over. Yeah, okay. I think that this is the correct behavior, actually. It is going to person 1. It is going to person 2, I want to say. Damn it, it's hard to tell. Let's have 3 people only. Did it jump what third of the way there? I don't know. I know. I will just mute this. And what we want is for the scene not to change again. There you go. That's the curve that I wanted. All right, fair enough. I think that this notion of who is the winner is good enough. To be on camera, you don't have to be the loudest. You just have to be louder than the person who was on camera before you. and you need to be louder by this margin. There you have it. You don't have to be the loudest. You just have to be louder. Are you still planning on converting this to C++ and making it into an audio unit and VST? Yes. The video portion of it is kind of interesting. I think that the video processor, so we have two ways of driving the Automixer for video. You have the post-production video processor in Reaper, and you have OBS for live broadcasts, and you control OBS using the Automixer Live. For the video processor, I don't think there is any chance, because as far as I know, VSTs cannot write into the global namespace that video processors would have access to. But whatever, Reaper people already have the JSFX version. And for the OBS version, it is possible to do it in C++ because you can use WebSockets in C++, and that's how we are going to communicate to OBS using OBS WebSockets. So I'm not only planning on making the Automixer for audio into an audio unit and VST, but I'm also planning on having the video portion of it with the OBS feature for live broadcasts. So yeah, I'm planning on making this into a VST. It will take a while. It will take a while. Okay, let's double check. So in this case, yeah, let's double check all the scenarios. Let's double check all the scenarios now that we made so many changes to the plugin. And we'll also commit the changes that we made. So, attack. To test attack, let's make the attack large so we can see it. And we just expect this transition to occur a bit late, just like that. On hold, let's make hold large, and we expect this transition to occur a bit late. Awesome. Then for threshold, we expect for this to not... Oh, hang on, this is gonna change. No, it's not. It's not going to change. It's going to keep it as it is because it's below the threshold. So we expect this transition to only occur here. Something weird happened. Let's revert the hold. Okay, that looks reasonable. Then for the minimum difference, in this test scenario, these two are too close. This person is just trying to interrupt that one. So that scene transition will not occur, and this will occur. Awesome. And then on this one, we will switch to this person, person 2. And let's make the bleed a bit lower. And let's also shorten this just so we can be sure that we switch to that person. Yes, we switched to that person. And same story here. These two test scenarios are actually super similar. But anyway, I'm gonna keep them both. All right, so this is it. We did a whole lot of weird edge cases, but we have now lots of control over when transitions are going to happen. From avoiding transitions when everyone is quiet to not switching to someone who is interrupting the first person and not flickering back and forth between two people who are almost the same level. And we don't switch too fast. So I think that this is good enough of a control when it comes to smoothing the scene transitions so that they don't jitter, they don't change scenes too fast. I think that this is enough of a control, and it sort of mimics how a human would behave, at least in a live broadcast when you cannot see ahead of time. And that's the case for the Automixer. We don't see the full timeline, we just see the audio as it's coming through. So I think I'm going to stop here in terms of this endeavor, for now at least. But there are, of course, other things that we want to do, like when we have been on a particular scene for too long, we want to add some variety. So maybe there is some kind of wide angle, or someone even suggested on the chat that we could just cut to a random person if there is no wide angle. I think I'm going to start with the wide angle, but anyway. So that's something that we can do. And maybe you would like for the look ahead for the camera to be different from the look ahead for the audio. That's an advanced feature. I don't know if I'm going to implement it, but anyway. We have more things to do, but in terms of smoothing, I think that we smoothed everything that, you know, in a way that makes sense. Cool. C++ is driving me nuts. I can't seem to wrap my head around it. Well, sorry to hear that. It happens. It is a complicated language and many ways to shoot yourself in the foot, and many historical features that you still see around because it's an old language. So yeah. But and the whole build tool is also kind of weird when you compare it to JSFX that just works. So yeah, I understand. If you have specific questions, then make sure to ask them. But other than that, I'm sorry to hear that. It is a bit like it. It gets better over time. It sure does. Anyway, that's it for this week. On Monday, I will be back and I will be working on the Automixer. Perhaps we will take a break from the video stuff and look at some audio stuff again. We have plenty of things to do there, and maybe even some visualization things. We'll see. Thank you, Bo and Mage, for being here on the chat with me. I hope you have a great weekend. Looking forward to seeing you again on Monday. And I'm signing off now. Bye. Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all be back together for some more coding or talking or chilling. The next time I'll be streaming.